Thank you very much. It's a pleasure to be here talking to you all. The title of my talk is An Uplifting Trifecta of War, Pandemic, and U.S. Carbon Intensity. I'm a faculty member here on the faculty in the business school in Tepper and here in EPP. So I want to talk about a research project that has three overarching questions. First, we ask, what do the available data say about trends in long run, and you'll see I mean very long run, economic development and sustainability through the lens of carbon emissions relative to output, relative to GDP. I want to take maybe a slightly different look at what those data tell us about sustainability by focusing on large-scale socially disruptive events and the role that they play in determining the path that we observe back over 200 years worth of data. In particular, I want to look at war and geopolitics. I want to look at the role of pandemics. I want to talk about business cycles, and then ultimately at the end of the talk, I'll refer a bit to public policy and its role. And then ultimately the goal here is to ask whether there are aspects of the historical context that teach us something about both the present and the path forward. So the message here is fully encapsulated by one graph. And what this graph is showing you is the tons of CO2 emissions from fossil energy sources, so coal, oil, and gas, in the US economy from 1800, so the country's 24 years old, to the present, to 2020, okay? And you can see that there's a dramatic peak in US carbon intensity, and that peak occurred in 1917. Now, if this were a smaller seminar group, I'd ask interactive questions about what happened after 1917, what happened in 1918. Number one, World War I ended in the fall of 1918, and number two, the Spanish flu pandemic broke out. Two key events that happened in 1918 that I'll talk about in a minute, and how that relates to mechanisms in this overall abrupt change in the path in US carbon intensity. The other thing to point out is a graph like this shows you a lot about the economic condition of the country, the recessions associated with the Civil War, the financial panics of the late 1880s, all show up in these data, okay? A stunning fact that comes from this data is fossil carbon intensity in the US economy in 2020 was approximately equal to what it was in 1840. Those are remarkable comparisons across roughly 150 years worth of progress and economic growth, pulling carbon intensity down to what it was in a period before the Civil War. Okay, so if we unpack that graph in very simple and stark terms, the role of coal is central in driving that peak and ultimately the turnabout in carbon intensity. What I'm showing on the left-hand graph, it's a little bit cut off here, is it's energy units from our three major fossil fuels: coal in black, oil in red, natural gas in blue. And you can see that that big peak, that big mountain that we saw that reached its climax in 1917 is really about the economy's reliance on coal as a primary energy source. Once that started to tip, once that started to decline as a source of energy in the US economy, then total carbon intensity started to fall. You can see that on the right-hand graph, that corresponded with the uptake of oil, the use of oil in the economy, and a few years later, the uptake of natural gas, while over the next 20 years following that peak, the share of coal in terms of energy relative to GDP fell by half. So this story is all about the use of coal. I'll jump way ahead and said if we're going to draw lessons in terms of global development, clearly we have opportunities for fast decarbonization if we move developing countries away from coal. Okay, so in terms of specific mechanisms, number one, the end of World War I and the Spanish flu pandemic resulted in dramatic reductions in the demand for energy, which at that time meant the demand for coal. With World War I, we're talking about transportation of things and troops and manufacturing, again, for the war effort. In terms of the Spanish flu, there were severe social disruptions, so we had lockdowns, we had masking, and we had social distancing, all of which reduced economic activity and the demand for energy. So just some pictures. This is a warship from the World War I era, clearly burning coal. This is a troop transport ship moving thousands of troops at a time from North America to Europe. Again, heightened demand for coal. This is a picture from Seattle. Social distancing and lockdowns and disruption of economic activity, all reducing demand for energy at that time. Again, right after that peak. There was a big disruption in labor markets, again, from this joint disruption of World War I and the Spanish flu, predominantly hitting working age men. That is, at that time, the labor force. So this led to turmoil in labor markets. That was especially true in coal mining, which reduced the production of coal, which raised the price of coal relative to oil and gas, moving us away from coal even more rapidly. Here we've got some pictures of working age men in an army barracks, all laid up from the Spanish flu, and we have women working in factories, which was a new development, again, supplanting the men that had been working there before the war and before the Spanish flu. Third, this was a period of rapid technological change. Although the dynamo had been developed decades before, it was at this period following World War I where we saw rapid deployment of electrification in factories. This improved energy efficiency and reduced emissions relative to output. This is showing you the old mode of production, which used the belt and pulley systems that were powered by on-site steam and therefore coal. When we moved to centralized power stations and economies of scale, we improved the efficiency of production and lowered carbon intensity by doing so. Okay, so three forces in the historical era. What does this tell us about the modern era? This graph is looking at the last 30 years, still looking at the US. We'll move to the international context in just a second. The top line is showing you GDP growth on a per capita basis. Over the last 30 years, real inflation-adjusted GDPs increased by about half. And then in these lower two curves, one's showing us consumption-based CO2 per capita and the other's showing us total inclusive of carbon embedded in trade. You can see 20% reduction, right? So this split between growth and CO2 emissions is a process we call decoupling, and we see evidence of it here in the US economy. I'm showing you this graph because it builds a connection between what we saw in the historical context, looking at the post-World War I and Spanish flu episodes, to the present, and makes us think about the future. So what do we have? In the right-hand vertical line, we have the coronavirus pandemic, which left a clear signature in both the GDP series and the carbon series. On the left-hand line, we have the great financial crisis. And absolute emissions, so this is no longer carbon intensity, but absolute emissions as well as per capita emissions in the US peaked in the years just before the great financial crisis. So again, the business cycle is important. Third, technological change in the period between the financial crisis and the present has seen dramatic retirements and reduction in coal-fired power generation in the US. Why has that happened? It's happened because of hydraulic fracturing and the abundance of natural gas and the low prices that were associated with that power source, and of course, the penetration of renewables into the grid. Why did that happen? Technological change, cost down, and policy help. Again, and finally, just off the right-hand axis of this graph, we have the war in Eastern Europe, the invasion of Ukraine by Russia, and that threw energy markets into turmoil, raised the price of natural gas and oil worldwide, at least on a short-term basis. So let's look beyond the US. This is a graph showing you 30 countries, from places as varied as Nigeria and Azerbaijan to Australia, Ireland, and the US. And it's showing the case of decoupling in all these different countries around the world. Decoupling, again, being the presence of economic growth, the blue line as measured by GDP, simultaneous with carbon reductions shown in the red line. So decoupling is happening, decoupling is broad-based, and decoupling is a tailwind for further efforts to reduce emissions. Okay, so just to wrap up some concluding thoughts. Number one, the global economy is decoupling. It's unpacking, it's breaking the link that we saw historically between growth and carbon emissions. Unbeknownst to most, that process started over 100 years ago in places like the US. Two, probably even more unbeknownst to most, the role of socially disruptive events has been at the fore when we look at the historical series and when we look at current events. This includes business cycles like the Great Depression, like the Great Recession. It includes wars like World War I, like what's going on in Eastern Europe. It includes pandemics like COVID and like the Spanish flu, and it certainly involves technological change. Just a concluding thought, when we look at the current pace of decoupling and the associated decarbonization that is implied by it, and we view that from the perspective of the 1.5 degrees Celsius target above pre-industrial, that climate scientists have coalesced around as a target to limit disruptive change from anthropogenic climate change, these sort of inherent rates, aided by policy tailwinds in some contexts, are not likely to get us there. So we have tailwinds. The costs may not be as high as we think because of these tailwinds, but we need to do more, and that's where we suggest the role for public policy. Thanks very much.
We have time for one question if anybody has any. You do have one. Oh, okay. Sure.
Nick, you talk about always per capita, and population growth, of course, is sort of busting all the boundaries. Should we be dividing by per capita consistently when we evaluate that fork?
So, two things. This peak corresponds to absolute as well, so total emissions, right? So it's not just about per capita. This peak in Western Europe, I would say that we observe the peak as well. As we move back the development scale, we have not observed that peak. And so the point I made at the end about achieving temperature targets is obviously driven by total emissions, and the comment about not moving quickly enough is the link between the per capita, the per unit GDP, relative to the temperature targets, which are driven by absolutes. So good news, tailwind, not a solution in place already. Fair point.
All right, thank you, Dr. Muller, for a great power talk.